Hello! Hi everyone and warm welcome to this webinar on open language models from potential to strategic value. And thank you so much for joining us today. My name is Henrik Rierfeldt, and just like yourself, I do my best to keep up with AI trends. My approach to shape my view of the now in order to guess the future is to understand the past, and I do this by talking to and listening to different experts. And today I have the great pleasure of introducing you to one of those experts. I'm very happy to introduce my colleague Magnus Hagen, who is head of research for a natural language understanding team, the team that, among other things, built the first Swedish LLM. And as you might have seen, AI Sweden was selected as one of very few organizations in the world who got access to test and evaluate open weight models released just after the summer by OpenAI. And the purpose of today's session is to share our first insights into this open model and different open models. And we also want to have an open dialogue on how these powerful new technologies can be adapted to Swedish needs and strengthening our national innovation and digital sovereignty. So with those words, super excited about this session. And please, Magnus, take it away.
Thank you so much. I'm going to share my screen. Okay, so the point of today's presentation will be to talk about open language models, and I don't actually seem to be able, yeah, okay, so now. So usually I start by going a bit back to the basics, just to make sure that we have a common understanding of what we're actually talking about here. So I want to dwell a little bit about the background of language models and how we actually train them, because I think it's important to understand also why we are now talking about the potential of open models. And I think a very technical explanation of a language model is that we want to have a statistical technique that can learn a probability distribution overlay. And the reason why we want to do that is because we can sample from that probability distribution. And when we do that, we generate language. And that's what we call a generative language model. A language model does not have to be generative. It can also be a representation of language. And in that case, we use the probability distribution as a representation and feed that into some type of classifier. And for those of you who work or have worked on language models, you recognize these as the early type of language models, like the BERT type of language models. These are a bit forgotten nowadays. They are still extremely useful, and you should not neglect that. But when we talk about language models today, we're typically talking about large generative language models that generate language. So this is also going to be the topic of the rest of these presentations, large generative language models. And the way that we train these models is we can call it a two-step process. So first we do something called pre-training, which is where the model learns the probability distribution of language. And this step requires large amounts of data. And the only thing that the model does when it actually learns this is to try to predict the next word. And as you can imagine, that's a very, very simple learning objective. And that is also the reason why we need to have so much data to train these models. And we typically train them on web data because we need to have large amounts of data. And today's most powerful open models have been trained on massive amounts of data, and I will come back to that later on. Now, when we have done the pre-training, the model will have learned language in a sense, and that is useful in itself, but a language model that has only been pre-trained is not very intelligent, so it does not understand how to follow instructions. And that is the reason why we typically also do something called post-training. And this is where we teach the language model how to actually behave in a linguistic way. You can maybe do the distinction between learning semantics in the first step and learning pragmatics in the latter stage. So when we do post-training, we typically feed the model with examples of the kind of tasks that we want the model to learn. So in the general sense, it will be instructions and it will be answers to the instructions. And when we do that, the model also learns how to follow instructions. And now the language model starts to become useful. We typically also want to make the model behave in a way that resonates with our values and our safety systems. And this is typically done by using something called reinforcement learning. And here we have examples of output that we want the model to produce and output that we don't want the model to produce. And this is an interesting step because this is where we teach the model to be helpful and truthful, maybe. This has also some unintended consequences, such as making the models to be very sycophantic. And you have maybe heard about AI psychosis and read interesting papers about that. This is the reason why the models behave like that. They want to support you because we train them to be supportive. Right? This is also the reason why the models also try to also answer questions all the time, and some people call that hallucination. And there has been some interesting lately work from OpenAI and others that show that it is in the post-training process where you actually reinforce these problems with the models. Right, so why am I talking about this? Well, it's important to understand why the open models are useful and how you can actually use them. And it's also important to understand the difference between different model providers. And I will come back to that in a very short while. But the point of doing all of this with a language model is that when we arrive at a model that has general text processing abilities. So these are general artificial intelligence systems in the text domain. Just want to strengthen that and point that out. Okay, so when it comes to large language models, this is a picture that I typically show when I talk about this. It's a picture that I have stolen from Google. It's by now quite old, but I think it sort of visualizes the general idea quite well. The reason why we want to build large language models is that they become general in a sense. They can handle lots of different types of tasks. So when we scale up the model, they become more general and they can start to solve tasks that we might not have sort of intended the model to solve. And when this development happened a couple of years ago, we were all quite surprised that the models would be able to do common sense reasoning, for example, or logical inference chains and stuff like that. But scaling up the model size is not the only thing that we do when we train these models. We also scale up the amount of data that these models are being trained on. And as I told you, this is in the pre-training step where we need the model to learn language. And today's models, today's leading models that are being trained by actors primarily in the US and in China are being trained on so much data that it's almost unfathomable. So the latest Quen model was trained on 36 trillion tokens. And a token is simply just the unit that goes into the language model. You can think about that as words. So 30 trillion words, and that's a lot of words. How much words are there? So just an example, imagine that we would take all the books stored in the National Library here in Sweden. I think this is a sort of semi-present estimate of how many books they get into the library. So 13,000 books per year almost. So just estimate that it's 300 pages per book, 300 words per page. That gives us 1 billion words per year. So we're going to need thousands of years of continuous publication before we can actually have the data enough to train one of these competitive large language models. And that shows that it's simply not feasible to go that way anymore. Just a brief recap of what has been going on in Sweden. And I think that some of you that are in the meeting might have been part of this journey and part of this history. The recent architecture for language models is typically based on a transformer neural network that was introduced in 2017 by Google. The year after, we started to see the first language models being built on the transformer, and those were models coming out from Google and OpenAI. So the GPT models were from OpenAI, they were generative by nature. Google produced the first BERT models, which were not generative by nature. We started the first national project here in Sweden on language models in 2019. The Language Models for Swedish Authorities project that I think some of you have been part of. The idea with that project was to foster the first development of language models in Sweden and try to look at applications in the public sector for language models. Those models were primarily based on BERT models from the National Library, so not generative ones. But in the middle of that project, in the summer of 2020, OpenAI released a paper on GPT-3, which was really the first large language model. And that was a transformative and disruptive paper in many senses. We thought that this was a development worth noting and trying to be part of, so we built the NLU group here at AI Sweden in 21 with the explicit intention of starting to try to work with large language models in Sweden. And in a collaborative effort together with the Wallenberg Autonomous Research Project, WASP, and others, we built the first LLM in 22, which is called GPT-Swi. That was not only trained on Swedish for the very reason that I talked about. It's difficult to get that amount of data in Swedish. So we trained it on Scandinavian data, open Scandinavian data sets from the web. The GPT-Swi models were the first Scandinavian LLMs. It was the first models in Europe being built from scratch, representing a smaller language family. And we spent almost a year trying to get the model to be openly released. That was the plan already from the start. It took us more than a year to actually get there. And in the end, it has been released as an open model. And this is the development that we are currently observing and that we are going to talk about. So the picture here to the left is just simply depicts the number of open models in relation to closed models. And this is based on data that is compiled by Stella Biederman, who's the research director for Eleuther AI, an open research collective in the US primarily. It's not completely up to date. There are so many open models nowadays that people have a hard time keeping up. But you can clearly see the trend. So from 22 onwards, open models have become the de facto standard when it comes to building and releasing models. The picture on the right tries to visualize what is sometimes referred to as the performance gap between closed and open models. And this is a picture that has been published in many different variations. This particular one comes from the CB Insights site. And it depicts the performance of a number of different models on a very specific test called MMLU, right? And what you sort of can allude to here is that the performance of closed source models, which is the blue ones in the sort of upper area, the performance gap diminishes over time with the purple ones that are the open models. Now, there's a lot to be said about this picture. So first of all, it doesn't, of course, tell the whole story. Closed models are still, I would say, outperforming all of the open models on very complicated reasoning tasks, for example. But what I think it demonstrates is that for specific tasks, the kind of tasks that I think are most interesting for most of you who attend this meeting, simple tasks like summarization or a named entity extraction or categorizing text or something like that. For most of those tasks, open models suffice in most cases. So instead of buying an API that can potentially be quite expensive and you have to send your data through an API, in most cases, it will actually suffice to download an open model and you can host it by yourself, have complete control over the data. And I think this is the main reason why we think that open models are so powerful. And you should always consider that as an option. Now, just considering our own development here in Sweden, we released GPT-3 all the way back in 22, which you can see was very early when you consider open models. It took us almost a year to get the model to be actually released as an open model, and by then several other open models have been released or had been released, and they were already at that time more powerful. I accidentally muted myself, but I'm back. um, so I just want to stress that even though GPT-3 was a very early model, by now it's severely outdated. It's still sort of good at generating fluent Swedish text. We did not do sufficient instruction training on the model. We did not do any reinforcement learning on the model, so it's not really intelligent. And there are much more useful options available, and we will talk about one of them later on, the GPT-oss models from OpenAI. Okay, right. So by 23, we had released the GPT-3 model as an open one. And now I think a question that some of you might ask is, why have we not released an updated version of this? Why has there not been any other generative Swedish models being produced since then? And the reason is that this is not a simple task to do. The amount of resources needed to train competitive open models today has massively increased since we built the first model. And today we need funding to do development projects. This is not about research. This is about building artifacts that produce actual value. And we know how to do it. We just need to follow the recipe. We also need to be able to use large amounts of data, trillions of tokens or words. This is challenging in Sweden, and it's challenging in the European context because we have very strict data protection regulations. This is great. I mean, we should not remove that, but we also need to find ways to work with that. And that has proven to be a challenging process, and we don't really have sufficient answers yet to that process. We also need infrastructure, of course. We need thousands of GPUs to scale these models up and to train them on very big data sets. Sadly enough, none of that is available in Sweden or even in the Nordic region, not for development projects that aim at producing valuable models. This is also one of the reasons why we are primarily now looking at open models being produced by external actors. So one example is, of course, the OpenAI collaboration that I will come back to in a couple of slides. But what we do then, instead of trying to produce national models, we now work on the European context. We take part in several European projects that aim to produce open models in Europe for Europe. And we're part of several of those initiatives. One is called Eurolingua, where we train models together with Fraunhofer for European languages. There is another project called TrustLLM that I will soon provide a little bit more information on. And we're also part of something called Deploy AI, which will provide the AI on demand platform for Europe, which also, of course, features open models. Just a few words on TrustLLM, because the focus there is also on open, powerful models. This is a project that is sort of going towards the end of its lifespan. It has been going on since 23. The coordinator is Linköping University here in Sweden. And the aim is to produce open, trustworthy, and factual LLMs, primarily for the Germanic languages. And as I said, working with data and trustworthiness in the European context is a challenging concept. And a lot of work in this project has gone into trying to untangle the complexities around working with data in the context of LLMs. There's been a lot of interesting developments there and a lot of work within this project on data compliance and how we should actually handle data training these models. And one of the more useful outcomes of this project is also a test suite for European models, which is called EuroEval. And you can find that on the web address there, euroeval.com. You can go there and you can compare different models on European languages, both generative models and non-generative models. And I think this is a very useful resource. We use it a lot when we compare models. We also try to contribute to this platform. And I really suggest that you take a look if you're interested in evaluation. Right. There is also a new project that we have just started, which is, we can describe it as a European concerted effort to try to build something very competitive here in Europe. And this is a project called Open Euro LLM, and I will soon come back to that. But first, talking about the European landscape when it comes to open models, this is a more or less complete picture when it comes to open language models that have been trained from scratch in Europe. I might have missed some models that have been released in the last couple of weeks or so. And if you do have a favorite model that I have not included here, please email me and tell me about the model. Otherwise, I think it's a more or less comprehensive picture of Europe. So you can see GPT-3 up there was the first one, and then we had a number of models coming out of Finland, the FinnGPT and the Viking and Pora models, primarily for Finnish languages, of course, but the Pora models are also, and I think the Viking models are also for Nordic languages and also European coverage. There has been a lot of development in France, primarily because the French government is very supportive of these developments, and they're trying to take a leading role in this, and they have really succeeded in that. The latest model that has been developed is called the Apertus model, which was released just a couple of weeks ago from Swedish, ETH in Zurich. And that's an interesting model because it covers more than 1,000 languages. It has been trained on open web data, and they claim that it's compliant and transparent enough to be of use in the European context with the data protection regulations. And I strongly suggest that you check that model out if you're interested in open models that support a lot of languages. And it's available for fine-tuning also, so you can update the model on your own data, and then it becomes more powerful than for your use cases. Now, looking at these models that are available, the Open Euro LLM project covers most of these. So all the green ones there are actually included in the Open Euro LLM consortium. So the general idea there was to try to build a European flagship project with only one focus, namely to produce open competitive models for the European languages primarily. And of course, these models need to be transparent, they need to be compliant with our data protection regulations, and they also need to be multilingual because we need to cover all of the European languages here. We have just started this project. It's been going on since, I don't know, February or something, and it will keep going for at least 1.5 more years. It includes all the, or most of the organizations in Europe that have proven experience actually working on open models, and these are the ones included. For those of you who are active in the field, you might notice that Mistral is not one of the companies here. They were invited and they declined the invitation, but we can do without them. And we are already starting to see some early results in this project. We are now at the stage where we are doing a lot of data experiments. So how should we actually structure the training data to attain optimal performance on all of the European languages? That's the picture on the right there. We have also released a number of monolingual models just as a first initial result. But the developments are ongoing. The plan now is to start training mid-sized models during the fall and winter, and then we are going to train our flagship models during next year, during the spring next year. And we're doing experiments on the optimal architecture of the models, and we can discuss that maybe later if some of you are interested. And all of the developments are, of course, also open, so you can follow that on the Open Euro LLM website. Right. So at the end now, I'm going to come to the actual collaboration with OpenAI. So as I've been talking about, open models have become the de facto standard in the field, and we already from the start, this was something that we have been promoting, and we strongly believe that model development should be open in order to enhance transparency, to provide trust in the models, and also the ability to actually download them and service them at your own sites and retain data protection for your own use cases. So looking at it from a sort of historical perspective, we have always believed in national development of LLMs. We think that that's really important for our sovereignty, our security, our resilience. I think we need to strengthen our position when it comes to development of basic models, but it has also become much more challenging. So the amount of resources that we currently need to compete with the powerful open models of the world is simply not available here in Sweden. So that's also a reason why we need to start looking at collaborating with actors that produce open models. So we can actually have some input into desired capacities, and that we also can have a collaboration on how we should actually fine-tune them and use them. And as I've been talking about, there's a lot of open models available, primarily from, well, actors in China, but also from the US. And all of those models are powerful. You can download the latest Qwen models from China or DeepSeek models, and they will be sufficient for most of your use cases. One of the problems with such models is that you don't have transparency of the data sets being trained, and you don't have any input into the desired capacities. And we have had an ongoing discussion with OpenAI for quite some time now on open models and the work that we do here in Sweden on LLMs. And when the discussions started around the topic of OpenAI releasing an open model, we were included in those discussions. And we were able to provide some input very early on in this process on how we were thinking about open models and desired capacities that we were gearing towards, and functionalities that were important in the use cases that we work on. Some of you might have heard of our Svea initiative, which is an initiative building a digital assistant for the public sector. That's a very important use case for open models, because the idea with all of the Svea initiative is to provide open and transparent technology for use in the public sector, and open models is of course a very basic component in that type of initiative. And so that was of course one of the use cases that we were talking to OpenAI about, and the kind of functionalities that we needed support for. As part of that collaboration, we also had early access to the models for testing. Already during the summer, we got access to preliminary versions of the models, and were able to provide some feedback into the functionalities and capacities of the models. And we are also now discussing continued collaboration, primarily when it comes to fine-tuning and adapting the models to kind of use cases that we are interested in and the kind of languages that we are interested in, and also other things related to the development of initiatives such as the digital assistant for the public sector. So when it comes to actually testing these models, I was talking about the Euro-Eval framework before, and that is sort of the best bet that we have from a European perspective when it comes to comparing capacities over languages. But it's also primarily based on machine translated test suites, and that is not an optimal way to test language models. So one of the things that we have done internally is to produce a Swedish benchmarked suite for language models. This is work done by Ariel Ekren in the NLU team here at AI Sweden. And it's based on human tests that you assign humans to. So högskoleprovet and apotekarprovet and matematik och fysikprov from KTH and things like that. And we think this is a very good way to test the reasoning capacities and the intelligence capacities of models. And if you look at the column with open weights, the red and the green dots there, the best performing model currently in these tests is the GPT-oss 120B model from OpenAI. And it's significantly, it's remarkably good at mathematics and physics, and you can see that in the score there to the right. That indicates that the model has been trained specifically for these type of tasks, and it has strong reasoning capacities, and it's good at instruction following. I should also say that even if this is a test that we now currently use to try to get an idea of the comparative capacities of models, open and closed, this does not really evaluate how good models are for actual generation of Swedish text. That's a very tricky question. It's an ongoing research topic. There are no solutions to this problem of evaluating actual generation. We typically just do vibe testing of models. So we tell them to generate a story, and then we see if the story makes sense, if it's grammatically correct, and if it produces good Swedish. And there are very few models that actually pass these type of vibe tests. Even the leading proprietary ones have problems passing just standard vibe tests for Swedish generation. That's not to say that no models do that, but it's still challenging for most models. But this is basically as far as we have come when it comes to model development and evaluation of open models. We strongly support this development. We think it's a very good sign that actors like OpenAI are open to discussing capacities and getting input from the community on what we need from open models. And we really hope that this development will continue. And I think from many practical purposes, we're sort of past pre-training. There are sufficiently powerful open models available. We should probably now focus on post-training and making sure that we deliver actual value from models in the concrete use cases that we are interested in. And I think with that, I'm going to stop talking.
Super, and I'll join you. Thank you so much, Magnus. This is great.